Can an infinite library hold every decimal number? At first, the answer seems obvious. If the library is infinite and the decimals are infinite, what's the problem? Let's start with whole numbers. Between 1 and 5, there are only 3. Between 1 and 100, there are 98. Between 1 and a billion, there are almost a billion. That's a lot. But here's the important part. You can count them all. You can collect them all. You can put every whole number between 2 points into a box. No matter how large the box needs to be, eventually, everything fits. Now let's look at decimals. Can we put those in a box too? That's where things get strange. Can we collect them all? Can we account for every single one? That idea leads us to something bigger. Imagine a library that never ends. Infinite shelves, infinite books, infinite pages. Now imagine every decimal number gets its own place inside. Every decimal, every page, every book. 1,000,000 books, 1,000,000,000 books, 1,000,000,000,000 books. The shelves continue forever. The books continue forever. The library itself is infinite. So let me ask again. Can an infinite library hold every decimal number? It feels like it should. If the library is infinite and the decimals are infinite, everything should fit. But in the late 1800s, a mathematician named Georg Cantor made a shocking claim. No. Even an infinite library would still be missing numbers. Not because it ran out of books, not because it ran out of shelves, not because it wasn't large enough. According to Cantor, no matter how many decimal numbers were already inside, you could always create one that wasn't. Think about that. An infinite library containing infinitely many numbers and still incomplete. How could anyone possibly prove something like that? And if Cantor was right, what does that say about infinity itself?